Example 3 says Mr. Kwan opens a boba stand outside of his house, but eventually he would like to open a location in an actual building. He invests $1,000 in an account that earns 6% compounded monthly. How long will it take until Mr. Kwan has $100,000 toward the purchase of his own space? So we know here that the future value of our annuity needs to be $100,000. That's the goal for my future value. That's what I'm looking ahead to try and achieve. And I know that my regular payments are going to be in the amount of $1,000. And my annual interest rate is 6%, but it's compounded monthly. So we need to take our interest rate of 6% and divide that by 12, which gives us 0.005. And our n value is going to be the number of months, which is what we're trying to figure out. Because it asks us how long will it take, and whenever we ask that question, we are asking for an amount of time. So recall that the future value of an annuity is equal to the regular payments times 1 plus our interest rate to the power of the number of terms minus 1 divided by our interest rate. So we can go ahead and plug in those values now. We have 100,000 is equal to 1,000 times 1 plus 0.005 to the nth power minus 1 all over 0.005. If you divide 1,000 by 0.005, that number happens to be 200,000. So I'm going to go ahead and cross those out. And then if I divide both sides of the equation by 200,000, then we would get 1/2 is equal to 1.005 to the nth power minus 1. And then if I added 1 on both sides, we would get 1.5, or 1.5 is equal to 1.005 to the nth power. Now take a moment to think back. How do we solve an equation where our unknown variable is in the exponent? If you said logarithms, you would be correct. So I'm going to utilize the natural logarithm. You can use whichever logarithm your heart desires. So I'm going to take the natural log of both sides. And that allows us to use the power rule for exponents. So we would get natural log of 1.5 is equal to n times the natural log of 1.005, like that. And then if we do some division, we will ultimately get that n is equal to the natural log of 1.5 divided by the natural log of 1.005. And if you throw that into your calculator, you should find that that is approximately 81.3 months. So because this, maybe I shouldn't box that. Because this investment is monthly, Mr. Kwan will be able to purchase his own office building or office location or whatever after 82 months. So Mr. Kwan needs to wait 82 months. That's a long time. Gotta put my boba dreams on hold. All right, let's look at example 4. It says a company establishes an official agreement to discharge a debt of $300,000 due in 5 years by making equal semi-annual deposits, the first due in 6 months. This is known as a sinking fund. If the deposits are placed in an account that pays 6% compounded semi-annually, what is the size of the deposits? So this is a scenario where we know our future value is 300,000, but we are trying to figure out what our regular payments are. So this is the unknown in this scenario. And the number of terms, we know that the payments are happening semi-annually, which means twice a year over the span of 5 years. So 2 times 5 is equal to 10. And our interest rate, our annual interest rate is 6%, which is 0.06. However, we are making payments twice a year, so we need to divide that interest rate by 2, which is going to be 0.03. And now we should have everything to be able to plug into our formula. So let's remind ourselves the future value of an ordinary annuity is equal to the regular payments times 1 plus our interest rate I to the power of n, which is the number of terms, minus 1 divided by I. Oops, so we know the S value is 300,000. We don't know what R is, and then we can fill in, let's see, 1.03 to the 10th power minus 1 over 0.03. So if I don't do any simplification and I just divide from here, we would get that R is equal to 300,000 divided by that big, ugly, hot mess. Sometimes that's my nickname, Big Ugly Hot Mess. Okay, and if you throw that into your calculator, you should get that R is approximately $26,169.15. So that means that each payment that the company makes, the regular payments, need to be in that amount.